Hello and welcome back to this session of Bioinformatics Bootcamp. This is now module 3 of this Bioinformatics Bootcamp IBMS pre-mat course. So we're going to be talking today about using the Tidyverse for practical data analysis. And we're going to be starting to get into a little bit of how you would use this on some real world and tangential to research data sets. So data sets that might actually come up in a research context. All right. Next time, we're going to actually do the full-on genomics project that I have planned for us. And that's where we're going to synthesize all the skills we've learned so far. And we're going to spend most of that last session actually doing the analysis and then talking about it. So what you've learned so far has been pretty difficult. Today begins the fun part, because today is when we're going to be talking about how to analyze data in a user-friendly and intuitive way, how to visualize that data using beautiful publication-ready plots, and then ultimately how to accomplish the fundamental tasks that data scientists need to accomplish. So with that, let's jump in. All right, so I've already got the RStudio loaded up here, and I've got it in module 3, but just to show you how I got there, let me close this again. And I'm going to just double click on this. I'm going to say open with RStudio. And it's just loading up. It takes just a second here. So now I've got it right here. Okay. And again, if you need to know where to get the code, that's the GitHub repository, which again, if you go to our website, which is www.bigbioinformatics.org. And you go to the R for Biomedical Researchers tab up here under workshops, you'll see the GitHub workshop repo right here. And one more time, if you want to, I'm going to put this in the chat really quick here. One more time, if you want to get the code, all you have to do is go to this button that says code, download zip, and this is where the code will be. That's where that R project will be. But I've already got it open, so hopefully this is starting to feel easier and easier as you do it each time. Let's just go forward with what we have now. Okay, so I actually want to go first through the homework from last time before we jump into the fun stuff today. So I've actually got the wrong R project open, but that's okay, because when you're in RStudio, switching between R projects is actually quite easy. You just go up here to the top right-hand corner where you see this name of our R project, Module 3, Tidyverse for Biologists. And you're just going to click this and then go to where it says Open Project. And then you can navigate to wherever you currently, or wherever you have the code downloaded, which for me is in my Downloads folder. And you can open up that Module 2 R project. Okay, so let's go ahead through the challenge problems from last time. Okay, so can anyone tell me what was wrong with this very first part here? How did you fix this? Does anybody want to put it in the chat? If you've got the answer, feel free to put it in the chat. Okay, Shahad, very good. Very good. It was missing a bracket. Exactly. And in fact, if you scroll over here, you see RStudio is actually trying to help you. RStudio says unexpected closing bracket. Well, that's because there was never any opening bracket to begin with. And now that we've got the opening bracket to complement the closing one, this for loop will work. So we can go ahead and run it here. And we see that, in fact, it does work. Okay, very good. All right. So what about for part 2? What was wrong with this? Now, again, remember the assignment was to correct the loops to get the output as the fruits. But what happens if I run this? Well, it outputs numbers. Can someone tell me how to actually make it output fruits instead of numbers? Okay, very good, Lauren. Exactly. Exactly. So we could just change this instead to be fruit var. Exactly. Very good. Okay, awesome. So any questions on either of these first two? Any questions on why these work? These were a little bit tricky. Well, again, if you have any questions at any point, please feel free to put them in the chat. I'm going to go ahead and move on to the next one now. Okay, so what we wanted to do was to write this such that we could skip the value orange when it arose. Does anybody know how to change what we have written here such that it will skip when fruit, when fruit brackets var is orange? Does anyone know how to do that? Okay, very good. Yes, again, Lauren, exactly. When this is equivalent to orange, we now do next. Now, we did not actually talk about this. Again, I said these were difficult problems. This was something that I'm pretty sure came up in data camp, but which we did not talk about actually the last time during our review. But that is exactly how this works. The next basically says skip one. So you can see here, when it got to orange, we skipped right over it. So we never actually printed orange, which is why you don't see orange here. Any questions on how next is working here? Or about how we're combining for loops and if else logic? Okay. What about part 4? This asks you to complete the function such that it takes an input x and outputs the cube of x, which is equal to y. Okay. Okay, very good, Shahad. That's very good. I'm going to show you one modification you can make. So this is what Shahad put, which is absolutely correct. All right, so y is x times x times x. The cube of x is y. Exactly. And then the last part here was, yes, exactly. I was about to say that's how you could actually have simplified this a little bit with exponentiation. Very good. Yeah, exactly. Exactly. All right, now how do we use it on the number 42? Yep, exactly. Yeah, we would just replace this with this 42. So we actually instantiated our function here. So now we've got our function in our environment. And now we apply it on a number. The cube of 42 is some big number. All right, very good. So now it gets more difficult. You have a class with several students. They just took an exam. Here are the results. So run that code. We can see everyone and the grade that they got. Now, the problem is to convert the numeric grades to letter grades using like the US scale, I guess. So assuming standard conversions, 90 is A, 80 through 89 is B, etc. The task was to loop over these grades, convert to letter grades, save the results in a new vector called letter grades, and then finally make a data frame, student grades, with columns made of letter grades, num grades, and students. Num grades was already up here. And then save it to a CSV file. So can anyone tell me how they solve that? Okay. You said you got stuck. Okay. So you've got what you got there so far looks good though. So let's start with what you've got there. All right. So this is what Shahad has. So for var in 1 through length, num grades var. Okay. If grade is greater than or equal to 90, then letter grades var will be A. Else, if grade is greater than or equal to 80, B, so on and so forth, right? So what was the next one? It was basically, and you could have just kept copying and pasting this as long as you wanted. All right, so 70 would be a C. 60 would be a D. Else, F. This is the sort of, I guess, American style here. So let's run what we've got so far. Now we see running it, we have generated our letter grades, B, A, C, A, B. And we also had our numeric grades, num grades, Johnny, Frank, Tim, Alice, Susan. And we can see that these are correct, right? These match up correctly. So everything's good so far. Now, how do we rope this all together into a data frame? Well, the first thing you want to do is just data.frame. Data.frame. And then we can put in here letter grades and num grades. And now you can see letter grades, num grades, and the names of the students right there. So again, this was something from Data Camp that we did very briefly touch on, but we didn't spend a ton of time on how to use data.frame to create a data frame, but this would be one way to do it. There are also others as well, but in this case, this is probably the simplest way. Finally, does anyone know how to save this as a CSV file? Can anyone tell me what command I would use to save this as a CSV file? To save student grades as a CSV file? Okay, so Lauren asks, do you not need to add the maximum like else if grade? No. So the reason is because, so let's say that our current grade, just for the purposes of testing, let's say that our current grade is a 70, or yeah, is a 70. Now, because this is false, and this is false, and this one is true, the way this is going to work is that it's going to test this, and then it's going to test this, and then when this is true, it's going to just run this and then stop. So you don't have to include the maximum because because it will stop at the first true that it hits. And so if it makes it to this part, we actually know that by definition, it cannot meet either of these conditions. So if we were to say, for example, like this would be the same thing. This would actually be redundant because we already know by definition, it has to be less than 80. Sorry, like this. It has to, by definition, be less than 80 because it didn't trigger either of these. Okay, cool. All right. So Francine put the correct answer, which is write.csv student grades. Exactly. Very good. write.csv, student grades. Except there's one thing missing. Can anyone tell me what is missing from this code on line 81? There's one thing that's missing. Nope, don't need var. So let's go ahead and take a look at the help page for write.csv. So looking at the arguments that are given, exactly, have we specified the file name? We haven't. Okay. So if I just open up a comma and so like I'm making a new argument, right? And I hit tab, I can see the arguments that are available to me. And I see file is one of them. So let's supply this argument, student grades.csv. Now we can see that this has been created right here, student underscore grades.csv. And if we wanted to, we could go into Excel and look at it and manipulate it there. All right, so hopefully most of you feel relatively comfortable with these concepts. While many of these concepts are not going to be something you have to do all the time, they are foundational to your use of R. They basically constitute what we call base R. Today, we're going to be talking about Tidyverse R, which frankly is a lot more fun to use than base R. But base R comes up a lot, and you will need to understand it in order to avoid running into issues later on as you start to analyze data. At the very least, it gets you familiar with how R works. Okay. So now we had challenge problems. These were very difficult challenge problems. Was anyone able to solve the first one? So just to reiterate here, you discover some genes which are associated with cancer progression. Cool. However, you know only the ensemble gene IDs. What is an ensemble gene ID? Actually, did anyone look that up? Does anyone know what an ensemble gene ID is? Did anyone look that up? So I'll show you here. We're going to talk about genomics in the next one, in the last of these workshop sessions. So this will be important to know at that point. So how do we specify genes, right? So let's say that you look for your favorite gene. Let's say I look for P53, and I just search P53 gene. Now, there's a lot of information about P53, especially for those of you who have a cancer background. This will be a very familiar name, hopefully. P53 is involved in a wide variety of pathways related to genomic damage response, DNA repair, and of course, cancer. So when we look for P53, we often see this funny thing, TP53. Now, it turns out TP53 is actually the real name, or at least the official name of the gene P53. But people tend to say P53. In fact, sometimes people don't even call it P53 or TP53. They have all sorts of names for it. And if you look back even a decade ago in the literature, you'll find all sorts of names that people have given to this gene. And it makes it really hard to actually know who's referring to which gene here. So Gene Cards is a very good resource that we use for understanding information about genes. We see this says TP53. We also see the other aliases or other synonyms used in the literature for this gene. So we see tumor protein 53, P53, LFS1. You see all sorts of them in here. But the big issue with all of this is that while TP53 is, quote, the official name, those official names do change over time. So maybe TP53 won't change, but another one might change. It's not stable. What we look for is a stable identifier that will not change, which refers only to that gene. There's a few different kinds here, as you can see, but the one that we typically like to use for a lot of our analyses in our lab is ensemble. So this is the ensemble ID for TP53. And if you click it, you'll go to their website. You'll see information about it. Ensemble's website is very slow. They need the new web dev team. That's okay. That happens. Sometimes there's not that much money in bioinformatics. Okay. So here's their page on TP53. So a very common way to do genomic data analysis is to use gene IDs rather than gene symbols or gene names. And the reason is because, again, they are very stable. And so even if you return to that data years in the future, you should still be able to analyze it. Whereas if you used gene symbols, those might have completely changed by then, and you might have a hard time actually analyzing that data. So a very common task is to convert between gene IDs and gene symbols. And that's sort of the premise here. So let's say we have 3 gene IDs, 3 genes that we want to study. These are our genes that we have found are associated with cancer. We need to now convert these to gene symbols. So let's say that we have a data frame called ID2 symbol. And this contains a mapping of gene IDs to gene symbols for a few genes. So we now need to make a function called gene ID converter that takes one argument, gene ID, and then must return the corresponding gene symbol for that ID it's been supplied with. Does anybody have the function code for gene ID converter written up? Was anyone able to solve this? How would you create this? Okay, so I'll show you here for this first one, and then I want you all to go back and do the others. Okay, see how far you can get on the others. But I'll show you the first one. So, gene ID converter, function, gene ID. So we start with the first part. It must be a function called gene ID converter that takes one argument, gene ID. And that's exactly what we've created here. Now we have to fulfill the second requirement. The function must return the corresponding gene symbol. So we already know it needs to return something. And we just, for the sake of consistency, we could just call that thing gene symbol. So how do we generate gene symbol from gene ID? Well, we could take our ID2 symbol object and use it to do that. So gene symbol could be ID2 symbol, gene symbol, where ID2 symbol ensemble is gene ID. This would be one way to accomplish that goal. Okay. And we can see that it does now, in fact, work. Because the way that this is working is it's taking all the gene symbols and it's going to find the one where the ensemble ID equals the gene ID you input. So if instead of this, we put in this one, we get back BRCA2 because that is the corresponding gene symbol for that gene ID. All right. Does anybody have any questions on why this works or have any questions on how this is working? These are very difficult problems, so take your time with them. It's actually, after today, I want to see if anyone is able to solve these. And you don't actually have to do it in base R. You can actually do it in Tidyverse R, which is actually slightly easier. But see if you can figure out how. It's good to challenge yourself because that is how we grow. And that's also how we learn in the first place. Okay. So before we move on to the before we move on, let's go ahead and take any last questions here on module 2. Then we're going to move on to module 3. Okay. All right. So let's move on then to module 3. And again, to do that, you could just go to where it says open projects. So you don't save here. Wherever you downloaded it to, and module 3. Okay. So today we're going to be working with the Tidyverse. The Tidyverse is a special way of using R. It's the primary way I use it, and it's honestly, if it wasn't for the Tidyverse, I would probably not be worth using. The Tidyverse kind of makes it the superior language for data science, in my opinion. Again, I know some people think Python's better, but I don't think it is. But if you didn't have the Tidyverse, not only would it not be the superior language for data science, it probably wouldn't really be that useful at all. So Tidyverse is an excellent way to use R. Let's talk about why now. I'm going to actually pull up the PowerPoint for today and give you a glimpse into this. So it all sort of hinges on this idea of the philosophy of data, why we analyze data, how we analyze data. Let's talk briefly about that. So it's a lot of what I'm going to talk about here is coming from the work of Hadley Wickham, who is one of the members of the RStudio core team. And he's the one who's developed a lot of the philosophy and a lot of the core tools that we use in the Tidyverse. This is the basic idea about how data gets analyzed. No matter how you are doing the data processing steps, the overall pipeline of data analysis will always follow this approach. You will always be importing data. You will always be tidying it, transforming it, visualizing it, modeling it, and then ultimately communicating it. Whether you do that in Excel or you do it by hand in, with like a piece of paper and a pencil, it doesn't really matter. You're always taking some input data, you're always transforming it, and you're producing an output, which you then communicate to others. This is the overarching flow of all data analysis. Tidyverse is a suite of packages that is built to capitalize on the best practices for executing this exact flow. So let's talk about it. So the Tidyverse is actually specifically designed to fit this model. Now, you have the importation of data using things like readr, Haven, and readxl, tidying of data using tidyr, transformation of data using dplyr, visualization with ggplot2, modeling with broom, and then communication with knitr and rmarkdown. And the nice thing about RStudio, which we're using for all of this, is that RStudio was also designed by the same people who made all of these tools. So using them all together, it's very synergistic. It's really the way R these days is meant to be used. So let's actually get started now. Let's actually jump into the coding. We're going to start with readr and dplyr. So if you'll recall, this is how you import data, and this is also how you go about transforming it. So go ahead and run these two lines here, install packages, Tidyverse and ggpubr. You will need both of these packages. It may take you a few minutes to actually get them all, but that's okay. Let's probably should have given a little bit extra time. While you install those, let's take a really brief break here. Probably give maybe 4 minutes. That's about how long I think it takes to install all of these from scratch. All right, I'm going to put a break in the video here. So go ahead and install those. All right, while those are installing, does anybody have any other questions? Any questions about R or any questions about, I don't know, rotations, grad school, that sort of thing? So you said you're having issues saving code in R. Okay, in R Studio. Okay. What happens when you try to save code in R Studio? Okay, when you open the file, the code is not saved. Okay. So, are you sure are you certain that you're actually saving it? Like you're like hitting Control S or you're hitting the save button? I mean, are you sure it's actually that you actually are manual? Because you do have to manually save it. Are you sure you're doing that? Okay, you need to be in a particular directory. So using the R Studio or the R projects can be really beneficial for this. So yeah, that's how I tend to manage, which directory I'm in, that sort of thing. Maybe that's part of the issue because if you're downloading the code multiple times, then if you save a copy of a script you've modified in one version that you downloaded last week, it won't be there this week. Because if you download it again this week, it won't be there. Yeah, you have to go back to the one you had last week. So like you can see, I've got, I've probably got seven copies of this at this point. And so each of them is different. And so if I do some work in one of them and save it, and then I open up a different one the next week, then it will not be there. It's only in the one that I saved it in. Yeah, RStudio is not smart enough to figure that out. Okay. Is anyone still downloading the packages? Anyone having issues getting either Tidyverse or ggpubr? Okay. Okay, you're all done. Okay, anyone? Okay, good. All right. So, I want to point out something before we start with this. I want to point out something that I think may be good to take stock of for everyone who is still here. So something that I've noticed tends to happen in these workshops is that people, they're very energetic, they're very excited to learn R and RStudio and actually get started with data analysis. But then you realize, during the very first session, typically, well, this is actually not quite for me, right? This is not really what I enjoy doing. I'm not having a good time. I'm not really feeling comfortable with the work that we're doing in terms of the difficulty level. And that's totally fine. You can always come back at any point, rewatch these videos. You can always come back and do data camp pretty much any point. I think the it's going to expire in November, but you can always get it yourself and continue going back. There's no reason why you have to learn everything today. My argument to do that, though, would be because you're about to start research, you're about to start rotations, and this would be a really good time to find out whether or not you want to spend the next 5 years, maybe in part or entirely, doing dry lab research, which, you know, I started out thinking I wanted to do mostly wet lab, maybe a little bit of dry lab. And then I realized pretty quickly after I started to do bioinformatics that, yep, no, I just want to do dry lab. So you might have the same experience, but it's good to find that out earlier if possible. So I definitely recommend doing it now if you can. All right. So let's move on to module number 3, which is the Tidyverse. All right, so go ahead, load up Tidyverse and ggpubr. Now, we have not yet used packages before, but packages basically, all they do is extend base R. They give you new functions that base R will not have by default. And that's what Tidyverse and ggpubr are for. Now, Tidyverse is funny because it's actually a collection of packages. And so when you load it using the library command, you actually get ggplot2, tibble, tidyr, readr, and so on. You actually get all these 8 packages at once loaded up. So this is really just a convenience function for that. ggpubr, we'll talk about later what that does. But for now, just know that this is sort of how you'll typically start something like this. You don't always have to include ggpubr, but you usually will want to include Tidyverse in all the beginnings of your scripts. Lauren says she had an error downloading the packages. Okay, can you put the text of the error that you got? I can basically predict what it's going to be, but I just want to make sure that I'm right. Unrecognized response install packages ggpubr. So did you yeah, I guess I'm confused. So okay, can you copy this and paste it in the command line? So, all right, we can cut this part out of the video if you want, but it may be easier if you share your screen. Yeah, Kate, your error is a different one. So these are 2 different errors. That one is definitely a little bit more arcane than the other, but I have also seen that one before as well. So, Lauren, would you mind possibly sharing your screen?
Yeah, that's fine.
Yeah, again, I think it's very helpful to show these errors because, you know, you're going to run into all these when you're first starting, right? All right. Okay, so oh, you're good then. Okay, good. So you got it.
Well, then it did that last time, but then it gives this error still, or at least that one.
Well, so you see where it says, do you want to install from sources the packages which need compilation? Did you say yes to that or did you say no to that? Oh, you didn't say anything to that,
I didn't
actually.
say anything to that. That's the problem.
Okay, so yeah, go ahead and run that line again, just by itself. Yeah, and then wait for it to ask, and then okay, so just the line by itself, because you see what you're doing is when it gets to the part where it's asking for yes or no, you're actually putting in that space install.packages ggpubr. So it's like, well, that's not yes or no. That's a that's a line of code, you know. So yeah, so just go ahead and type in yes there.
Okay.
Yeah, you should be good now.
Thank you.
Yeah, no problem. Let's go to the other one, since that one's definitely a more fun error. Simon, did you, because I it takes me a minute to Google this one whenever I see it. Do you want to did you look that one up already? Because I can also look it up here. I can show you how to solve that one, basically.
No, I haven't looked it up yet. I figured you would know it by heart, to be honest.
Yeah, no, I don't know it by heart because I don't have, I think this is like, are you on a Mac? Or is this on Windows? Kate, are you on Windows or are you on Mac?
This is Mac.
Yeah, so yeah, this is the Mac one. All right, so if you just take the text of that error and you paste it into your search bar, you'll basically see other people kind of talking about the same issue. So let's go ahead to the first answer here. So the first question is this actually your error? Well, this looks very similar to your error, so probably is your error. And then they actually solved it themselves. So there you go. So basically, whatever the packages are that, So whatever the packages are that you need to have installed, maybe you'll have to do them separately using install.packages. I don't really entirely know why this happens. Maybe someone's got a better answer down here. I'm not really willing to dig too much farther into it at this moment to find out, but try installing readr by itself, because you can see there it says there's no package called readr. So try doing install.packages readr and then just by itself. So like that would be like this. Like this. So instead of doing Tidyverse, you could do install.packages readr install. Oh, you've got an old version of RStudio?
Yeah, so it was because I remember in the first class, there were some issues with the Big Sur Mac versus,
Right.
I forget what the other one is. So what we ended up doing was we had to load the Big Sur version of R and then also the previous version of RStudio.
Oh no, wait, what version of R are you running?
Just the one before, the one for Big Sur, as opposed to the one for whatever the current Mac build is, because the one for current Mac build only works for M1 processor Macs and not for Intel ones.
Oh man.
Yeah.
I mean, not to say anything bad about, Mac OS, but I will never switch from Windows. All right, but do you have 4.1.0? Or do you have like an older one?
You can check.
It should say here somewhere. Anyways, it's fine. So I would just, if you get those errors, just look and see which package it's failing to load and just do install.packages that package. So go ahead and try that with readr. RStudio version. Well, what version of R do you have?
So it'll say in your console.
Yeah, if you scroll to the top of your console, it'll say here.
Yeah, or also like at the top left of your console, next to your path.
Well, that might actually be a new RStudio thing.
Oh, okay.
That might be a newer RStudio thing. Yeah. All right. That one is the one from, yeah, that one's older. Okay. Okay, so did this fix the issue with readr? Okay, yeah. Would you mind then, would you mind sharing your screen? All right, so if you scroll to the top of your console, so if you go into where your console is and then just scroll up all the way to the top. Oh, okay, it's gone on too far. You can't even reach the top of it. Oh no, that's fine. That's fine. It's all good. So, can you scroll now down to the bottom of your console? Let's see what you're failing to install here. So go ahead, try installing readr. Ah, good, exactly. Okay, this is the error I was looking for. Yes, Xcode. Yes, you've got older app, older Macs. So older Macs have this problem. Older Macs need Xcode. Oh, right. That means you'll have to install Xcode. Do you know how to do that? Does another Mac person know how to do that? I honestly have no idea how to do that. Just gonna double check, make sure Tidyverse actually needs Xcode. I think it does though, unfortunately. Yeah, I think it does, unfortunately. Okay, well, I'm really sorry about that. Yeah. So I think you're probably gonna have to go in and install Xcode. And yeah, hopefully it won't take terribly long and then you'll be able to join us. I really don't know. Does anyone else here have a Mac? Does anyone else know how long it takes to install? Okay. If not, I'm gonna move on while you do that. All right. All right, so okay, so you're also having an issue with the Tidyverse package. Okay, what's the issue that you're having? Can you share screen? This is good. We'll like stall while Kate installs Xcode. Yeah, which by the way, you have to install that from the App Store, it looks like. I didn't know if you knew that. Okay. So yeah, so go ahead and okay. Is that the issue that you said you were having? Was that error? Why do people have older versions of RStudio? Are you on Mac as well?
It was actually saying that before it was saying that Tidyverse package doesn't exist, and then I installed readr, so it looks like it might be actually fixing the issue.
Oh yeah, yeah, exactly. Yeah, because it won't exist until you install it. Yeah. Exactly. Yeah. Okay, good. Very good. Yes, try to get the latest version of RStudio when you get a chance, though. It will make your life a lot easier. And it'll be a better experience. RStudio is a very, I guess, tech-forward company. They do a lot of really excellent work. You really kind of want to keep up to date with what they're putting out, because it will usually be the best practices and the most efficient tools. All right, so go ahead, load up these libraries. Hopefully everyone, except for Kate at this point, will be able to follow along. So the first thing that you're going to do is you're going to want to read in a data set that we prepared here called Titanic.csv. Can anyone tell me what CSV stands for? Does anyone remember?
Comma separated values.
Very good, exactly. Comma separated values. So if we take a look at this in our file system here, we can see this data set, Titanic.csv, and now it will actually prompt me to open it in Microsoft Excel. All right, good. So we can actually see this data here. Okay. Something strange with it, but pay no mind to that for right now. I think Excel has just gotten very confused when it opened this up. But basically, you can see here, it contains a column called survived, a column called P class, name, sex, age, sibling/spouses aboard, parents/children aboard, and fare. So hopefully you all are up to date on your maritime history, and you recall the Titanic was a big ship back in the 1800s at some point. They made a big famous movie about it, and famously, a lot of people died on it because it hit an iceberg and it sank. Now, this is a data set that actually includes the manifest of the passengers who were aboard the Titanic. And we know whether or not they lived or died. 0, for survived means they died. 1 for survived means they lived. We also know what class of ticket they had. Was it 1912? Wow. Oh, shoot. I'm bad at history, apparently. Thank you, Simon. P class is what is the class of their ticket. So 3rd class, 2nd class, and 1st class. 1st class being the most desirable, most expensive ticket. Name, so the person's name. Their sex, male or female. Age, how many siblings or spouses they had aboard, how many parents or children that they had aboard, and the fare that they paid for their ticket. And the question is, do any of these features give us the ability to predict whether or not that passenger lived or died? This is, if you are familiar with machine learning, you'll recognize a classic machine learning problem. In fact, it is a classic binary classification problem. Now, we're not actually going to be developing any models today, but we are going to do the exploratory data analysis that is done during machine learning in order to decide on how to engineer your features, how to select features, and ultimately how to build a predictive model. But today we'll just do the exploratory data analysis in R. So first thing we want to do is read in the data, and we use read underscore CSV to accomplish this. Now, this has given us a little message here. It says rows 887, columns 8. So it's telling us about our data. There's 887 rows and 8 columns. It also tells us here that we have 2 columns, name and sex, which are character. So basically, it's tried to determine what kind of data you have in each column. It has 6 columns that are DBL. This is short for double, which is a synonym for numeric with decimal points, right? So this is just a numeric. So there's 6 numeric columns: survived, P class, age, and so on. The reason that it does this is because it's actually trying to help you understand your data even before you begin processing it. It also says the delimiter is a comma. This is a comma separated value CSV file. So the delimiter should be a comma. So it's gotten all of this correct. Very good. Now, if we print our Tidy Titanic in the console here, we see that it doesn't look like a normal data frame. There's something special about it. Not only do we see all of our columns, but we also see the types of data in each printed below it. And we also see this little message here that says 887 by 8. So it's telling us additional information here. It's actually helping us a lot more than a typical data frame would. And that's because it's not actually a data frame. So can anyone tell me what is the class of Tidy Titanic? What is the class of this? Does anyone know? What is the class? This is the first challenge problem. What is the class of Tidy Titanic? Okay, Francine says data frame. Well, can anyone tell me the code that you would use to determine the class of Tidy Titanic? It's a particular function. Exactly. Very good job. Exactly. So what is the output of class Tidy Titanic? So the output, class Tidy Titanic, spec TBL DF, TBL DF, TBL data frame. What does this mean? Well, it turns out objects in R can actually have multiple classes. So in fact, this is at some level, this actually is a data frame. At a deep level, it is. However, it's also TBL, TBL DF, and spec TBL DF. These are actually special Tidyverse classes that are what account for why this doesn't look like a typical data frame. So we can convert it to a data frame if we want to. We can say as.data.frame, Tidy Titanic. And now it prints it as a data frame, which is kind of gross and hard to see. But we don't really want that. We would actually prefer if it was like this. So this is typically referred to as a tibble. Tibble is the name given to that collection of 4 classes. And this is the base class for all data in the Tidyverse. So we use Tibbles, that's what they're called. Now, in the Tidyverse, we use these intuitive, what are called verbs for analyzing our data. If you recall from our PowerPoint here, the steps of the data analysis pipeline are actually always basically the same. And so what Hadley Whitcomb and RStudio have developed is a unified grammar for describing these steps. And that's exactly what we're going to be using now. It's basically the grammar of data analysis. So one of the verbs in that grammatical workflow is called filter. So this would be equivalent to saying, I want to filter Tidy Titanic such that age is greater than 12. So age is one of the columns in Tidy Titanic. So we're going to filter it such that age is greater than 12. Now we have 808 observations, and we can see that we've lost from originally we had 887, we've lost a good number, but that's because now we only have the passengers whose age is greater than 12. This actually was a mistake. I wrote this challenge question before before it was like this, and I was going to ask how would you modify Tidy Titanic, but then I decided to give it to you, but I forgot to delete this. My bad. Ignore this for right now. Okay. So now we've modified Tidy Titanic. All right. Any questions on the filter verb, on how this is working? This is one of the simpler verbs in the Tidyverse. Okay. Well, if you have any questions, feel free to stop me at any point, and we'll get into them. So, okay, so Matthew asks, can you filter characters and doubles? Yes, absolutely. So can anyone tell me how I might construct a filter such that we only keep the passengers where their sex is male? Thank you, Matthew, for proposing a good challenge question. So I'll show you here. So this would basically be filter, Tidy, Titanic, where sex is male. And you can see, again, this is the grammar here. This is why now 532, because we've gotten only the males, and you can see sex only male here. But this is why this is a grammar. Because we can say in natural language, I want to filter Tidy Titanic such that sex is male. Or I want to keep the parts of Tidy Titanic where the sex is equal to male. Right? But now I have not modified Tidy Titanic, so it still has 808, because when I did that filter, I didn't reassign it. So I haven't actually modified it. So it still works here. But just to answer your question, yes. Anything that would produce a true or false, or a logical vector, anything that will produce a logical vector can be used here. Okay. So next up is mutate. Now, mutate is a verb that adds a new column or modifies a column. Basically, you can modify a column based on some operation. So in this case, we're going to do an if else. And we're going to say if survived is 1, then yes, if not, no. And we're going to reassign this to the column survived. So we're basically converting our survived column, which is zeros and ones, into yeses and nos based on whether or not it's a 1. So ones should be yeses, zeros should be nos. If survived is 1, it's yes. If it's not, then it's no. All right. And we take another look at this, and we see now where we originally had zeros and ones, we now see yeses and nos. Any questions on how I did this mutate, on how mutate is working? Typically, mutate is always going to modify an entire column, either adding a new column or changing an entire column all at once. Okay. All right, so hopefully you all did the data camp assignment and this won't feel too foreign because this is really hinging on you having done that. All right, so next up is select. So select is just going to choose columns. It's basically just a way of picking particular columns that you want to keep. So in this case, I want to keep Tidy Titanic, survived, and sex. Or sorry, from Tidy Titanic, I want to keep survived and sex. Sorry, I said that backwards. So now you can see I have selected only survived and sex from Tidy Titanic and then reassigned all of that back to Tidy Titanic. Next up is the group by verb. If anyone's done SQL before, this should all be ringing a bell because a lot of this is borrowed directly from SQL. So group by. So we're going to take Tidy Titanic and group it by sex and survive. Now, why do we want to do this? Well, we'll get to that in a second, but let's take a look at Tidy Titanic. So now it looks the same, except for one key difference. It now has this line, groups, sex, survived, 4. Can anyone tell me what the 4 refers to in this groups line here? Can anyone tell me what the 4 refers to? Exactly. Very good, Lauren. Possible groups. That's right. Because you can only be yes or no for survived, and you can only be male or female for sex. Therefore, we can only have 4 possible groups of survived and sex. So those are the possible combinations of survived and sex. Only 4 are possible. Exactly. Very good. So the final part here is we now want to ask this question, right? We're curious, is there an impact of sex on survival aboard the Titanic? We're just exploring that possibility now. It was a common saying back in the, I guess, early 1900s, my bad again, that, you know, when you have a naval disaster, men should stick behind and it should be women and children first aboard the lifeboats, right? So we might hypothesize that there would be a relationship between sex and survival. And perhaps we would hypothesize that women were more likely to survive than men aboard the Titanic. And so how can we test that? Well, we could summarize our groups here and see if numerically more women are surviving than men. So let's test that now. We're going to use something called a summarize in order to accomplish that. Now that we have made our groups sex and survived, the summarize is going to take our groups and it's going to perform an operation using them. In this case, we're just going to perform an operation called N. N is simply a way of counting up all of the observations within the groups that have been defined. We're going to take N and assign it to a new column called N sex survive or N sex serve. So now we now have our 4 groups: female, no, female, yes, male, no, male, yes, and the number of observations in each group. So, any questions on how summarize is working so far? One thing you'll notice is that we've done something which, again, if you're familiar with SQL, this should be ringing a bell, but we've done something called a roll-up. Basically, we now have only sex in our groupings. Originally, we had sex and survived. But when you do a summarize, what Tidyverse will do is it will take the most recent group you defined, which in this case was survived, and it will remove it. and it will leave you with any groups that you have remaining. And if you have no groups remaining, then you will just have no groups at that point. There's a particular reason this is done, because in the flow of data analysis, you typically want to do these roll-ups as they were, but that's what it's called. It's called a roll-up. That's why you now have one group missing. You can actually control that behavior and get it to not do that, but for right now, we don't mind it. So, challenge question. Why can we not directly compare the number of men and number of women surviving? Why can we not directly compare row 2 and row 4? Does anyone know why we cannot directly compare these values? Very good, Matthew. The reason is because the total number between the groups is different. The total number of men is different from the total number of women. Yeah, and Kate had the same answer. Very good. Yeah, exactly. The reason is because what if, so let's say I'm trying to compare these, right? And there are, I'm seeing 213 women surviving to 86 men surviving. But what if it was the case that there were actually just in total 3 times as many women aboard the Titanic as men? Doesn't really seem likely, but let's say that was the case. Well, then this would actually be no difference really, or a very minimal difference between them. 213 and 86 would actually be about what you would expect by random chance. So we need to actually normalize, or sorry, not normalize, we need to standardize the data based on the total number of men and the total number of women. All right. So to do that, we're going to use an approach called percentage. And I'm sure all of you are familiar with what a percentage is. It's actually an approach that you can use to standardize data and make a fair comparison. So what we want to do is have the percent of women surviving, percent of women not surviving, percent of men surviving, and percent of men not surviving. And then you can compare these percentages directly because they are now standardized. So to get a percentage, just to review here, we're going to use the sum function, we're going to use division, and then we're going to use multiplication. So let's say that you have a numeric vector 158. The sum function is going to add up all of the elements of that vector. Now, if you wanted to get the percentage contribution of each element to the total, well, you could do the vector divided by the total times 100. And now you get 7%, 35%, 57%, right? This all adds up to 100%, but you can now see the relative contribution of each element of that vector, right? So this corresponds to 1, 5, and 8. So that's how we get percentages in R. Now, we're going to use a mutate, and we're going to make a new column called PCT sex served. This is going to give us the percent of each sex surviving. Okay, so mutate is a funny verb because mutate can not only just add a new column, but it can also respect groupings. Right now, we have a particular grouping, sex. When we run this code, even though we haven't had to explicitly specify it, it's going to do these sums within each sex. Okay, so it's going to do the sum, and it's going to do this entire calculation actually within each sex. Okay, so rather than doing the sum over all of the total number, it's going to do it within sex. And that's because we have our groups still present. And that allows us to get our percentages. So now we've got our percentages here, and you can see they add up to 100 within each sex. Okay, so that's a lot to start with there. Does anybody have any questions on what I just did, on how I was able to get that? On why that worked? That was actually a pretty complex operation I just performed there. Okay. All right. Well then, let's put it into practice. Can anyone tell me how you would get the sorry, how you would filter tidy tally to only include the percent surviving, and then assign that to a new variable called PCT serve. So go ahead, take your code, put it here, and then once you've got it, please put it in the chat. Well, let's start off with just the very first part of this. So what tidyverse verb would I use to perform this operation? Does anyone know what tidyverse verb I would use for this? Okay, good. You would use filter. All right, so that's the first part, filter. So what are we filtering? So the first thing that we put into filter is the data that we want to filter, right? So we put in tidy tally. Now, the challenge is to include a statement such that we only have the percent surviving. You can see here right now, tidy tally includes the percent surviving and the percent not surviving. So how can I filter such that I only get rows 2 and 4 here, where survived is yes? How would I do that? Okay, so if you come up here, okay, good. Exactly. Survived, yes. Exactly. There you go. And that's how you would do it. And now I've just got the 2 rows where survived is yes. And this is now our percent survive. And now this is what we would compare. So the way we've done this so far is actually not the tidy way. The tidy way involves unbroken, clean data processing pipelines. And to get these pipelines, we use the pipe operator. This is a mainstay in the use of Tidyverse. So here is everything we just did, but the tidy way. So you can think of it like this. If I'm talking in natural language about the way I want to analyze my data, I say, well, first I read in my data, and then I filter it, and then I mutate it, then I select columns, and I group them, then I summarize them, then I mutate them, then I filter them. And that's how I get my results. The way that this pipe operator works is basically it takes some data and it passes it to the next function after performing an operation on it. So the data comes in from right here, and then it gets passed to filter, then passed to mutate, select, and so on. This is identical to what we just did, but in a much cleaner and ultimately much more rigorous and reproducible way. You'll save yourself a lot of time by using a pipe flow like this. And ultimately, your code will be much easier to maintain and much easier to understand when you come back to it later. All right, so let's go ahead and run it. And we see we get the same answer. So any questions on this, on how the pipe operator is working? The only thing that it really changes is you don't have to provide the data each time because it's actually being provided already by the verb that preceded it. So mutate modifies the data and then supplies it to select. Select modifies the data and supplies it to group by, and so on all the way down the line. Okay. So would you do the above first? No. In fact, I would never, this is why I actually kind of struggle with explaining this because I never do it this way. This is just to show you how the verbs work. In practice, I always do it this way. This is exactly how I always do my data analysis. Yeah. Because when you do things in this sort of broken way, it's very easy to make a mistake. This way, it's much harder to make a mistake. Yeah. So if you deleted literally everything above, if you just deleted all of that, this would still work just fine. It doesn't make any difference. See, still works just fine. And I'm going to leave it deleted. So, I mean, hopefully you didn't delete it if you really need to see the stuff above. That's totally fine. But this actually captures everything we just did. So don't really need to have it. All right. So hands-on activity. What I want you to do is to, okay, so for the sake of time, I would say, let's just do this for homework. Let me get through the rest of this and then I would say do this for homework. Okay. Because we're definitely not going to get through all this if we stop for the hands-on activities. Sorry about that. All right. Let's move on to ggplot. And I promise I will go over the answers to this next time. I will do it kind of briefly though. So ggplot is back here in this PowerPoint. ggplot, as you can see, is the visualization portion of the flow. GG in ggplot stands for the grammar of graphics. That's what GG stands for. And comes from this book long time ago, back in the 80s, by Leland Wilkinson. And in this book, they basically describe how all plots, all statistical plots can be broken down into a series of layers. These are those layers: data, aesthetics, geometries, facets, statistics, coordinates, and themes. Grammar of graphics is a structured language by which you can control these layers to create any kind of visualization which you need to, easily and in a straightforward, human readable manner. Here's an example of one of the plots that is produced using the grammar of graphics in ggplot2. You can make very elegant looking plots that very succinctly describe complex data. So you can see here, year over year, the temperature fluctuating. Here are some plots from a paper I published last year that I made with ggplot2. This was actually my figure 1. So you can see you can make very nice publication quality plots using nothing but R. All right, let's actually do it now. So ggplot2. The first part of setting up a ggplot is to set the data and the aesthetic layers. So the data layer just is your data. In this case, we've got PCT serve, which we created not so long ago. It's really quite simple data. There's only 2 observations, but it's enough for us to do a plot. Our mapping is the way that the axes, X and Y, relate to the data. So X will be sex, Y will be PCT sex serve, and fill will be sex. So we want to color it by sex. You'll see why in a second. So we run this and it makes a plotting object, PLT. If we plot, or if we run that PLT, you can see it shows the plot right here. There's nothing there yet. See, nothing there, but there will be soon. The reason that there's nothing here is because we have not yet added our geometry. So let's now add our geometry layer. So we're going to do PLT plus geom col. This stands for the column geometry. This is sort of a unique type of bar plot. Now that we have added our geometry layer, you can see our data very clearly. You've got male and female, and you have the PCT sex serve. Quick challenge question. Oh, so first, before we do that, Francine asks, is fill and color the same? No, they are not. If I change this to be color instead, you'll see they are not the same. Color actually just colors the edges of the geometry. So you can see it's kind of gross looking. Yeah, not really ideal. Usually you'll want to use fill when you're doing like a bar plot or something like that. All right, quick challenge question. How could I change the above code so that I plot, instead of the percent sex survive, the number sex surviving? How could I do that? Can anyone tell me how I would change it? So instead of PCT sex serve here, I want to have the number sex serve, which I think was this column here. Can anyone tell me how I would modify the code to do that? Okay, so you could modify the X, but the X is sex. What do I, Y? Okay, good, good. Yeah, it's not the X we want to modify, it's the Y. So instead of Y being PCT sex serve, Y will actually be N sex serve. Now you can see the absolute number of each sex surviving. Okay, yeah, sorry. All right, but we don't want to do that because, again, we already explained why that's not quite ideal. So we'll put it back the way it was, but just know that you could do that if you really wanted to. All right, so let's start cleaning up our plot, making it something that we might actually publish, okay? So first thing, let's add a human readable Y label. So we want it to be sex surviving instead of this PCT sex serve. Okay. So we've added that, plotted again. Now we see percentage surviving here on the Y. All right, let's now remove the X label because we don't really need it. Male and female, that's fairly explanatory for most, people who are going to view the plot. So we just set X lab as null. That would be how you would remove that X label. And now you can see sex is now gone. Next up, let's add a title to our plot. We'll call it Effect of Sex on Survival Aboard the Titanic. And to do that, you use the labs function with the title argument. So you can see how layer upon layer, we're building the aesthetic elements of our plot here. Sorry, well, yeah, they are aesthetic. Yeah, the aesthetic elements of our plot. Now we're going to add a theme. Often we want to do this because I don't know about you, but I don't really care for the, the base ggplot theme. I don't think it looks very nice. So we're going to add a theme and we're going to set the font size slightly higher so it's easier to read. Now, theme classic was just a helper function that allows us to set a lot of elements of the theme without having to put in much effort. One of the things, though, that it doesn't allow us to do, which we might want to do, is to remove this legend. Because again, we have male and female here down on the bottom. We don't necessarily need this legend here, even though it's nice they give it to us by default. So to remove the legend, we use the theme command and we set legend position equal to none. So a lot of what I'm doing right now comes from a lot of experience that I have using ggplot. But let's say that you don't have so much experience and you want to look it up. There are a variety of cheat sheets out there. And at the end of this, I'll show you one of them. But for right now, just know that these are all things that you could very easily Google if you wanted to. And there are a lot of cheat sheets for them. So I'm not just like intuiting this out. It's something that I've learned from practice and from a lot of Googling. So the next thing is that we probably want our percentage to go from 0 to 100, not negative whatever this is to 80, right? Because percentages, we kind of want that to be 0 to 100. So to do this, what we're going to do is set the limits of our y-axis to 0 to 100, and we use the scale y continuous command to do that. We also set expand as 0, 0, and that means it's not going to put this extra white space around our geometries. Already much better. So this is almost looking ready. The last thing that we might want to do is change male and female to be capitalized. So we could add scale X discrete and add some labels here. So these labels basically indicate female, capital F, male, capital M. And now this is looking pretty good. So as I'm sure you're picking up on, this is not the way I usually do this. I usually do it in one big pipe. Can anyone tell me how you might do this as a pipe? And then I will get to Matt's question in a minute there. It's a good question. How do you center the title? So can anyone tell me how you might do this as a pipe? And just a quick hint, you will not use, it's not like this. The pipe in ggplot uses the plus sign. So that was just, that's the only hint I'm going to give you here. Yeah, exactly. Exactly, Lauren. You can just put them all in one line with the plus in between. Yep, exactly. So let's do it. So we take this and then we add plus and then we add geom call plus ylab. It's going to get a bit tedious, but this would be how we would actually do it typically, like that. So again, usually you want to make things as a big data flow. You don't necessarily want to have things kind of separated on separate lines. It's a really easy way to make a mistake. It's a really better practice to have everything as part of one big pipe if you can. And it's much easier to read when you do it like that. All right. So now we have it all one pipe. So if I clear the plots and I run this, you can see it makes the plot just fine. We could also assign it to a variable, PLT, and then we'll have PLT. Again, PLT works just fine. All right, so Matt asks a really good question. Can you center the title? I don't know. Probably you can, but I'm not sure exactly how. Let me show you how you would find out the answer though. ggplot2, center, and even before I finish typing it, it's already auto-suggesting center title. Stack Overflow, very first thing that comes up. Got a lot of upvotes. You got to give it an upvote because, you know, you had that question too. So it was a useful question. How do I center this title? Okay, so GG title The default is left aligned. All right. They're showing you here. Theme plot title equals element text HJust 0.5. So this stands for horizontal justification, HJust, horizontal justification. And if we set it to 0.5, that means it'll be in the center because 0 to 1, 0.5 is in the middle of 0 and 1. All right. Let's actually do it now. Let's add our horizontal justification. And there you go. Good question. Oh, I forgot to upvote the answer. Wait, no, there we go. Modern computing would collapse without Stack Overflow. All right. So I also had a hands-on activity for this, but I want you all to do it on your own time because I want to make sure that we end on time and that we get to the last part, which is probably my favorite part when I was first learning, which is how do you do stats? How do you do all of this? How could I never purchase a license for Prism again, basically? All right, so let's show you how. So we get our plot. So just in case you didn't sort of see the connection between these, you can actually pipe your data right into ggplot. You don't actually need to supply your data explicitly because when you use the pipe operator from a pipe flow, it'll pipe it right into ggplot. So we're going to take our data, we're going to filter it such that the age is greater than 12. We're going to change the columns to be yes or no for survived, and then we're going to pipe that right into our plotting. In this case, let's say we want to ask a question. Let's say that we think that there is some relationship between the price of a ticket and whether or not that person lived or died aboard the Titanic. Let's say that we think that, it was the early 1900s, maybe, there was more classism or less classism. I don't know. But let's just say that we believe that people who had a more expensive ticket are more likely to survive aboard this Titanic. So we might do a box plot to help show that. And we might want to have our X be survived and Y be the fare price. Let's look at our plot. So we can see we've now got our box plot here. And we use the geom box plot to do that. It's our box plot geometry. So hopefully this is making sense how I'm getting to this. Basically, it's what we just did above, except with more data points. So one thing you'll notice already from these box plots is that the data is not normally distributed. Let's say we want to do a t-test or something like that. Well, we want the data to be normally distributed. We might think to ourselves, well, okay, I could probably log scale it and maybe that'll fix it. So let's try log scaling this. And not only that, but like it also helps you visualize the data to see it normally distributed. So to log scale our data, we just add plus scale y log 10. Okay. All right. And now we can see log scale, much easier to see the differences between them. And the yes is now pretty normally distributed, although the no is not really normally distributed, even with the log scaling. All right. Any questions on how we got this? And then I've got a challenge question on why we got this warning. But first, any questions on how we got to this point? Okay, so quick challenge question. We got this warning message. It said transformation introduced infinite values in continuous y-axis. And then it says removed 15 rows containing non-finite values. So basically it said for some reason our data transformation created infinite values. How is that possible? Does anybody have an idea of how this log transformation might have created infinite values? Does anybody have an idea of what could have caused that? Anyone remembering how anyone remember how the log works? All right, so I'll give you a hint basically. Ah, good, exactly. Log of 0. What is the log of 0? Any log really of 0. It's not 1, no. It's negative infinity or undefined basically. And the reason is because the log is the power that you would raise something to in order to get 0, but there's no way that you can raise anything to a power that would provide you with 0, right? So a log of 0, undefined, which is why, but it approaches infinity, right? So that's why when you attempt to do a log of 0 in R, it will give you an infinite value. And we can't really plot infinite values very easily, so they get removed. So how can we deal with that? Well, we can just filter our data such that the fair has to be greater than 0. All right, so we see this all in one line now. No warning this time. Didn't really change much, but that's okay. So now let's say we want to apply a test of means to this. We want to see whether the mean is really different between these two groups. This would be like a t-test, or in our case, we don't have normally distributed data, so we'll probably want to do a Wilcoxon rank sum test, which when you do your stats class next semester, you'll see all about that. So to do that in R is actually very simple. All you do is add the stat compare means to your plot, and it will do the test. All right. So let's take a look now, and we can see it has put the p-value right here. The p-value was so low that it was less than 2.2 times 10 to the negative 16th, which is all that it's really willing to do. You can actually control this behavior. You can make it print the official p-value, but usually this is enough for people to say, okay, probably significant. All right, so all in one line now, we have read CSV, filter on age, filter on fair, mutate, and then do your plotting with the stat compare means. And we've added one thing here. Let's say that instead of having it like this, we wanted to have the nice brackets with the stars, the way that we typically see it in the literature. Well, you could actually do that by adding this comparison here. So we want to compare yes to no. That's how we create the brackets. To make the stars, we do label equals p dot significant. And then when you run all of this, you get something that is pretty good looking. So I would say that is a pretty good looking plot, but not quite publication quality. So very final part here, we add a few additional items just to make it look a little bit nicer. And that's starting to look a lot better. And we can now save this to a file, and you can put it as a PDF, a PNG. You can do whatever you want with it. In this case, I'm going to save it as a PNG, and you can see it gets saved right here. We use the ggSave function to do that. ggSave just takes the ggplot and saves it to a file. All right, so let's go to where I just saved that. And it's right here. And I would say that is a pretty good looking plot. That is pretty much ready for prime time. At the very least, it'll look pretty good in a lab meeting presentation. So you can see like why I don't use Prism, because I can make something that honestly looks nicer, and I can do it faster just with R. So ggSave is how you save the plot. So ggSave, then you put the plot you want to save in here, the file name where you want to save it to, the height and width in inches of the plot, and that will just save it. I'll show you here now how to do PDF as well. So we just save PDF. All we have to do is change PNG to PDF, and it's automatically now a PDF. And if I want to, I can take this PDF, I can open it up in Illustrator, and I can do any other tweaking that I feel like I need to do. So pretty good. All right, so We went through a ton today. I had prepared some practice problems for you all here, where you'll be using the iris dataset in order to do some analyses. I do not think you're going to get through this by tomorrow. That's okay. You have plenty of time to learn. I will go through this. I'll actually make videos. Even if we don't get to this tomorrow, I'll make some videos and upload them to the YouTube channel in case you want to see the answers to these. But for right now, just know that these are some pretty good fill in the blank and then challenge problems. And then finally, there's at the very end, like an extreme challenge problem, which is actually the professional quality bioinformatics training that I do with people that I collaborate with. So you'll see it here at the very end. Basically, the requirement is to go through here and to analyze the Gapminder data set, which is a data set that contains information about countries over the years, such as their population growth, infant mortality, things like that, and asks you to analyze them using various statistical tests. This is a very difficult challenge, as people who have done it before, I think Simon among them, can attest. So don't worry about trying to get this done before next time. What I would say that you should probably try to do is to go back and do these hands-on activities here. This will give you the most direct reinforcement of the skills we talked about today. And then next time, we're going to be analyzing COVID genomes. So I've decided, basically, since COVID is starting up again, probably will be topical again by the time people watch this video. Unfortunately, we'll be analyzing COVID genomes. And if I can get my hands on it, we'll be analyzing the Delta variant genome, because that is quite topical at the moment. And I think it'll be cool to see how it compares to the other variants. All right. So with all that being said, does anybody have any questions on what we talked about today? Any questions on what we're going to be doing next time? I'll post the, I'm going to post some stuff for it actually just in a few minutes here. I haven't posted them yet, but that way, if you want to take a look ahead of time at it, you're welcome to do that. But it's also okay if you don't have time. We'll go through it in the first 30 minutes or so. You'll have about an hour to work on it. And then we'll go through it together at the end. It'll be a fairly simple assignment, but it will involve a lot of the skills we've talked about so far, plus a little bit of genomic data analysis, which should prepare you pretty well to start working with some real world data sets once you get into your research. Okay, so any questions, any last questions people wanted to have addressed? Okay, well, if not, then I'm going to stick around for a few minutes to answer any lingering questions, but if not, if you don't have any, then feel free to peace out, and I will see you all tomorrow. Okay. Okay, sure. What can I help you with? Okay, let me